The Milky Way Galaxy is our cosmic home, a giant city of stars floating in the vast universe. When you look up at the night sky and see a faint, milky band stretching across it, that is part of our galaxy, seen from the inside. The Milky Way contains hundreds of billions of stars, along with planets, gas, dust, and dark matter that we can't see but that makes up most of its mass. Everything we know, from the sun and the earth to all the other planets we've ever found, lives inside this enormous system. Even though it feels like the stars are spread everywhere, they all belong to the Milky Way's structure, held together by gravity. Scientists think the Milky Way is about 13.6 billion years old, forming not long after the Big Bang. In its early days, it was much smaller and grew over billions of years by merging with other galaxies and collecting gas from space. That's how it became one of the large spiral galaxies we see today. The Milky Way isn't a flat disk. It has a spiral shape with long, curving arms that stretch out from the center, where a huge black hole sits. This black hole, called Sagittarius A*, has a mass equal to about 4 million suns. Even though it sounds frightening, it's so far away that it poses no danger to us. The black hole plays a key role in shaping the galaxy and affecting how stars move around it. Our solar system sits on one of the spiral arms, known as the Orion Arm, about 26,000 light-years from the galactic center. A light-year is the distance light travels in 1 year, almost 6 trillion miles. That means the light we see from the center of the galaxy left there 26,000 years ago. From our location, we're safely far from the crowded, dangerous regions near the center, but close enough to enjoy a clear view of our galaxy's wonders. If you could travel out into space and look at the Milky Way from far away, it would look like a glowing pinwheel with arms curling around a bright central bulge. Each arm of the Milky Way is filled with billions of stars, and many of those stars have planets orbiting them. Astronomers estimate there could be more than 100 billion planets in our galaxy, and some of them might even have conditions similar to Earth. That's one reason why scientists believe life could exist elsewhere in the Milky Way. There are also star clusters, groups of stars born together from the same cloud of gas and giant nebulae, which are colorful clouds where new stars are forming. In a way, the Milky Way is alive. Old stars die, their gas returns to space, and new stars are born from that material. This cycle has been happening for billions of years and continues today. When people long ago looked at the night sky, they noticed that milky-looking band across it but didn't know what it was. The name Milky Way comes from ancient Greek, meaning milky circle. Early astronomers thought it might be clouds or something supernatural. But that changed in 1610 when Galileo Galilei used a telescope and discovered that the Milky Way was made of countless tiny stars. Later, scientists like William Herschel and Edwin Hubble helped us understand that our galaxy is just one of many in the universe. In fact, there are hundreds of billions of galaxies, each with its own stars and planets. The Milky Way is only one part of this huge cosmic ocean. The galaxy itself spins slowly. Our solar system takes about 230 million years to make one complete orbit around the center. That means, since the Earth was formed about 4.5 billion years ago, we've traveled around the galaxy nearly 20 times. Everything inside the Milky Way is in constant motion. Stars orbit, clouds of gas move, and gravity shapes everything. Even though it feels like space is still, it's actually full of motion on a grand scale. If we could see time sped up, we would watch the galaxy's spiral arms twist and drift like waves. The Milky Way isn't alone in space. It belongs to a group of nearby galaxies called the Local Group. This includes the Andromeda Galaxy, which is larger than ours, and the Triangulum Galaxy, along with dozens of smaller dwarf galaxies. Andromeda and the Milky Way are slowly moving toward each other. In about 4 billion years, they will collide and merge into a single, larger galaxy, possibly forming a new elliptical galaxy. Even though that sounds like a cosmic disaster, individual stars probably won't collide because the space between them is so vast. It will be more like two giant clouds passing through each other and slowly combining. Despite how enormous the Milky Way is, we can only see a small part of it with our eyes. Most of the galaxy is hidden behind clouds of dust that block visible light. To study it, astronomers use telescopes that detect other kinds of light, like infrared and radio waves that can pass through the dust. These tools allow scientists to map the shape of the galaxy, measure the motion of stars, and understand how everything fits together. From these studies, we've learned that the Milky Way has a thick disk, a central bulge full of older stars, and a surrounding halo where old star clusters and dark matter live. The dark matter halo is especially mysterious because we can't see it, but it provides most of the galaxy's gravity, keeping everything bound together. Even though we live inside the Milky Way, it's so huge that we'll never explore most of it. The fastest spacecraft humanity has ever built would take tens of thousands of years just to reach the nearest stars. Still, the idea that we are part of this vast and ancient structure connects us to something far greater than ourselves. Every atom in our bodies was created in stars that once lived and died somewhere in the Milky Way. When we look at the night sky, we are literally seeing the place that made us. As we keep exploring the Milky Way, it's amazing to think about how scientists can study something so big when we're stuck inside it. Because we can't step outside and take a picture of the whole galaxy, researchers have to piece together clues from what they can see. They look at how stars move, how gas clouds are shaped, and how light behaves across the sky. By comparing this data with images of other spiral galaxies, astronomers can build a picture of what our galaxy looks like from the outside. The result is a model that shows a beautiful spiral system about 100,000 light years across and roughly 1,000 light years thick. That means if you could fly across the Milky Way at the speed of light, it would still take 100,000 years to cross from one side to the other. The galaxy's spiral arms aren't solid like the arms of a pinwheel. They're more like waves of stars and gas moving through the disk. These waves create areas where gas clouds are squeezed together, and those areas are where new stars are born. The Orion Arm, where our solar system lives, is one of these active regions. Many of the bright stars we see at night, such as Sirius and Betelgeuse, are part of this same arm. Other major arms include the Perseus Arm, the Scutum Centaurus Arm, and the Sagittarius Arm, each filled with star clusters and glowing nebulae. The spiral pattern of the Milky Way is what gives it its beauty, but it's also what drives its constant change and renewal. The center of the Milky Way, where Sagittarius A times is located, is a very different environment. There, stars are packed thousands of times more tightly than in our neighborhood, and gas clouds swirl in extreme gravitational fields. Even though the black hole itself doesn't emit light, it influences everything around it. When gas and dust fall toward it, they heat up and release powerful radiation, creating bright X-ray and radio emissions that astronomers can detect. Using advanced telescopes, scientists have even captured images showing stars orbiting the invisible black hole, proving it's really there. This discovery confirmed decades of research and showed how gravity shapes the heart of our galaxy. Beyond the bright disk of the Milky Way lies a large, faint halo that extends far into space. This halo contains very old stars and ancient globular clusters, tight groups of hundreds of thousands of stars that have existed almost since the galaxy's birth. Some of these clusters orbit far from the main disk, showing that the Milky Way once merged with smaller galaxies. When two galaxies combine, their stars and gas mix together, leaving behind streams of stars that can still be traced today. These stellar streams help scientists learn about the Milky Way's history, revealing a story of constant growth through cosmic collisions. Dark matter plays a huge role in all of this. Even though we can't see or touch it, dark matter makes up most of the Milky Way's mass. We know it's there because of how stars move. They orbit faster than they should. If only visible matter were present. This invisible material forms a vast halo around the galaxy, stretching far beyond the visible disk. Without dark matter, the galaxy's stars would fly apart into space. It acts like an invisible glue, keeping everything bound together. Understanding dark matter is one of the biggest challenges in modern science, and the Milky Way is one of the best laboratories for studying it. Closer to home, our solar system orbits quietly within the galaxy suburbs. The Sun and its planets move at about 514,000 miles per hour around the galactic center. Yet it doesn't feel like we're moving because space is so empty and vast. Our corner of the Milky Way is relatively calm, which is lucky for us. Nearer to the center, there are more radiation bursts, supernova explosions, and dense clouds that could make life difficult. Here, 26,000 light-years away, the environment is stable enough for life to thrive. The Sun follows a gentle path through space, rising and dipping slightly as it travels around the galactic plane. When we look up at the Milky Way from a dark place on Earth, we're seeing the light of about 100 billion stars blending together. Each point of light is a sun, and many of those suns may have planets orbiting them. Some might even have moons, oceans, and possibly life. In recent decades, Astronomers have discovered thousands of exoplanets, planets outside our solar system, using telescopes like Kepler and TESS. These discoveries have changed how we see our galaxy. We now know that planets are common, and that many stars, perhaps most, have at least one planet. This means the Milky Way could be filled with countless worlds, some rocky like Earth, and others made of gas or ice. The search for life in the Milky Way has inspired both scientists and dreamers. The idea that we might not be alone in our galaxy is one of the most exciting questions in all of science. Some researchers listen for radio signals from intelligent civilizations, while others study planets in the habitable zone, where liquid water could exist. Even if we haven't found alien life yet, the odds are in favor of its existence. With so many stars and planets, it seems unlikely that Earth is the only place where life has appeared. The Milky Way may hold thousands, even millions, of civilizations at different stages of development. Some could be primitive, others might be far more advanced than us. But the Milky Way also reminds us how fragile we are. Space is full of forces that could easily destroy life. Supernova explosions, gamma-ray bursts, asteroid impacts, and more. Yet somehow, our planet has remained safe long enough for humans to exist and wonder about our place in the galaxy. This sense of belonging to something enormous gives many people a feeling of connection and humility. It's incredible to realize that every atom in our bodies came from stars that lived and died in the Milky Way long before the sun was born. We are, quite literally, made of stardust. When we gaze into the night sky, we're looking through one small part of a spiral arm. But our imagination lets us picture the whole thing. Modern telescopes, both on the ground and in space, are helping us see farther and clearer than ever before. Projects like the Gaia mission are mapping the positions and motions of over 1 billion stars, giving us the most detailed picture of the Milky Way's structure and motion. Every bit of new data helps scientists understand not just where we are, but also how our galaxy moves, grows, and changes over time. It's a cosmic detective story, and we're only at the beginning. As scientists continue to study the Milky Way, one of the biggest surprises is how dynamic and alive the galaxy truly is. It's not a frozen, unmoving system. It's full of motion, energy, and change. Stars are born, live their lives, and die in brilliant explosions. Gas clouds drift, collide, and collapse to form new generations of stars. Even entire star systems are slowly pulled or pushed around by gravity. Over millions of years, these movements create patterns and structures that define how the galaxy looks. The Milky Way is always evolving, and though the process is slow by human standards, on cosmic timescales, it's constantly transforming. At the heart of this cosmic activity are the nebulae, huge clouds of gas and dust that serve as the birthplaces of stars. Some of the most famous ones, like the Eagle Nebula and the Orion Nebula, are located within our own galaxy. These glowing clouds are lit up by young, hot stars forming inside them. As gravity pulls gas together, it heats up and begins nuclear fusion, the process that makes stars shine. Over time, new clusters of stars emerge, surrounded by leftover gas that eventually drifts away. These newborn stars start their lives within the Milky Way's spiral arms, adding fresh light to the galaxy's glowing pattern. But stars don't live forever. Massive stars burn their fuel quickly and end their lives in spectacular supernova explosions. These blasts release enormous amounts of energy and scatter heavy elements like carbon, oxygen, and iron into space. Those elements become part of new gas clouds, helping form new stars and planets. Smaller stars, like our Sun, live longer and die more quietly, shedding their outer layers and leaving behind small, dense cores called white dwarfs. The death of stars is as important as their birth because it enriches the galaxy with the materials needed to create planets and, eventually, life. Every bit of gold, oxygen, and carbon on Earth came from stars that lived and died long before our Sun was born. Our solar system formed about 4.5 billion years ago from one of these recycled gas clouds. The Sun ignited in the center, while leftover material formed the planets, moons, asteroids, and comets. This all happened within the Milky Way's Orion arm, and since then, the solar system has been traveling around the galaxy together. As it moves, it passes through regions with different densities of stars and gas. Sometimes the solar system encounters cosmic clouds or nearby supernova remnants, which can slightly change its orbit. But overall, the Sun's path has been stable enough for life on Earth to develop and survive. Over the billions of years of its history, the Milky Way has been shaped by countless collisions with other galaxies. Astronomers know this because they can see the remnants of smaller galaxies that were absorbed long ago. Streams of stars that stretch across the sky mark where these ancient mergers happened. The Milky Way has also captured many small satellite galaxies that now orbit it, like the large and small Magellanic Clouds visible from the southern hemisphere. These dwarf galaxies are slowly being pulled apart by our galaxy's gravity, and their stars will eventually become part of the Milky Way's outer halo. This process of merging and consuming smaller galaxies is still going on today, showing that the Milky Way continues to grow and change. In about 4 billion years, something much larger will happen. The Milky Way and the Andromeda Galaxy are on a collision course. Right now, Andromeda is about 2.5 million light-years away, but it's moving toward us at about 250,000 miles per hour. When the two galaxies meet, they will begin to merge into a single, massive galaxy. At first, their outer stars will pass by each other, creating long streams of light and dust. Over time, their gravity will pull them together, distorting their shapes until they finally combine. Scientists think this new galaxy will be an elliptical galaxy, larger and rounder than either of the originals. Even though this sounds dramatic, it's unlikely that any stars will actually collide because the distances between them are so vast. Our solar system will simply move into a new orbit as the galaxies blend together. The Milky Way is also surrounded by invisible companions made of dark matter. This mysterious material doesn't emit or absorb light, but its gravity affects everything. It shapes how stars move, how galaxies form, and even how the universe evolves. In the Milky Way, dark matter creates a massive halo that extends far beyond the visible disk. Without it, the galaxy couldn't hold itself together. Scientists are still trying to figure out what dark matter is made of. Some think it's a type of particle that interacts only through gravity, while others propose more exotic explanations. Whatever it is, it makes up about 85% of the Milky Way's total mass. Aside from stars and gas, the Milky Way also contains vast regions of interstellar space, huge areas that seem empty but are filled with very thin gas and magnetic fields. These regions are the galaxy's background, connecting everything together. Radiation from stars travels through this space, and cosmic rays, high-energy particles, zip around at nearly the speed of light. These rays can affect how clouds form and how stars are born. Even though interstellar space looks empty, it's an active part of the galaxy's ecosystem. When astronomers map the Milky Way using radio waves and infrared light, they can see details that are invisible to the human eye. Radio telescopes can detect cold hydrogen gas, the raw material for star formation, while infrared telescopes can see through dust clouds to reveal stars hidden inside them. The result is a detailed picture showing where stars are being born, where old stars live, and how the galaxy's spiral arms move. Telescopes like the Hubble Space Telescope and the James Webb Space Telescope have given us stunning images of nebulae, clusters, and the galactic core, helping us understand the Milky Way's structure better than ever before. The more scientists study the Milky Way, the more they realize how interconnected everything is. The galaxy isn't just a collection of random stars. It's a complex, living system. Each part affects the others. The black hole in the center influences how gas moves in the inner regions. Supernovae spread elements that form planets. Gravity keeps everything in balance, while motion keeps everything changing. It's a delicate, cosmic dance that has been going on for billions of years and will continue long after our species is gone. The Milky Way also reminds us of our place in the universe. Even though it's enormous, it's still just one of billions of galaxies that fill the cosmos. Yet, for us, it's home. Every story we've ever known, every civilization that has ever existed, every person who has ever looked up at the stars, all of it has happened within this one galaxy. From our small planet, orbiting an average star, we are part of something ancient and magnificent. The Milky Way is not just where we live, it's part of who we are. When you think about the Milky Way, it's easy to picture it as a peaceful, silent place filled with glowing stars. But in reality, the galaxy is full of activity and energy. Every second, countless events happen across its vast regions. Stars explode, planets form, gas clouds collide, and black holes feed on surrounding material. Even though these things happen so far away that we can't feel them, they constantly reshape the Milky Way structure. Space may seem quiet, but the galaxy is always alive with motion and transformation. One of the most powerful events in the Milky Way is a supernova explosion. When a massive star reaches the end of its life, it collapses under its own gravity and then explodes outward with incredible force. A single supernova can shine brighter than an entire galaxy for a short time and release more energy in a few seconds than the sun will emit in its whole lifetime. These explosions are important because they scatter heavy elements like iron, calcium, and gold into space. Without supernovae, planets like Earth couldn't exist, because those elements are the building blocks of rock, water, and life. The debris from a supernova eventually mixes with surrounding gas, forming new clouds that give birth to the next generation of stars. It's a never-ending cycle of creation and destruction that keeps the Milky Way evolving. Some of the most beautiful and mysterious regions of the Milky Way are the nebulae left behind by dying stars. The Crab Nebula, for example, is the remnant of a supernova that exploded almost 1,000 years ago. At its center is a rapidly spinning neutron star, a tiny, incredibly dense object that's all that remains of the original star's core. These nebulae glow because the energy from the remaining star, or neutron star, lights up the gas and dust around it. In other cases, planetary nebulae form when smaller stars like the Sun shed their outer layers at the end of their lives. These delicate, colorful clouds can last tens of thousands of years before fading away. Together, they decorate the Milky Way with stunning patterns of light. The Milky Way's spiral arms are where most of the galaxy's star formation happens. These regions are full of gas and dust, the raw material for new stars. Astronomers call this part of the galaxy the stellar nursery. Within these arms, gravity pulls clouds together until they collapse and ignite. Young stars often form in groups called open clusters, which can contain anywhere from a few dozen to several thousand stars. Over time, the stars in these clusters drift apart, becoming part of the general star population in the disk. Our own sun may have once belonged to such a cluster billions of years ago before wandering off on its own. Between the arms, space is more empty and calm. Older stars drift quietly in these areas, far from the busy star-forming regions. Many of these stars have stable planetary systems, and some might even host life. Scientists believe that the conditions for life are better in these quieter zones, where there are fewer supernova explosions or bursts of radiation that could damage planets. The Milky Way's vastness means there are many such calm neighborhoods scattered throughout, giving plenty of opportunities for life to develop in different places. The center of the galaxy, however, is a very different story. Near the black hole Sagittarius A asterisk, everything is extreme. Stars there orbit at incredible speeds, and clouds of gas spiral inward under intense gravitational forces. Even though the black hole itself is invisible, the material around it heats up as it falls in, producing X-rays and other high-energy radiation. Astronomers have even seen bursts of light coming from the center when the black hole consumes a passing cloud or star. Despite its violence, this region is also fascinating because it helps us understand how galaxies evolve. The activity around Sagittarius A types may influence the entire Milky Way, affecting how gas moves and where new stars form. Surrounding the central bulge is the galactic disk, which contains most of the galaxy's stars, gas, and dust. The disk is shaped like a giant pancake, about 100,000 light-years wide, but only about 1,000 light-years thick. Our Sun lies near the middle of this disk, not too close to the center, and not too far toward the edge. The disk isn't perfectly flat. It bends and warps slightly, like a spinning record that's been bent out of shape. Astronomers think this warp might be caused by the gravitational pull of nearby galaxies or dark matter. As the Milky Way spins, the disk moves and ripples, showing that even the galaxy's large-scale structure is flexible and alive. Outside the disk is the galactic halo, a huge, roughly spherical region that extends far beyond the visible stars. The halo contains ancient stars and globular clusters, dense groups of stars that have been orbiting the galaxy since its earliest days. These clusters are among the oldest objects in the universe, some more than 12 billion years old. Studying them gives scientists clues about how the Milky Way first formed. The halo also contains dark matter, which we can't see, but which provides most of the galaxy's gravitational mass. Without this dark halo, the Milky Way wouldn't be able to spin as fast as it does or hold its stars together. The Milky Way doesn't exist in isolation. It's part of a cosmic neighborhood called the Local Group, a cluster of about 50 galaxies bound together by gravity. The largest members are the Milky Way and the Andromeda Galaxy, while the third largest is the Triangulum Galaxy. Around them orbit many smaller dwarf galaxies, including the Magellanic Clouds and the Sagittarius Dwarf Galaxy. Some of these smaller galaxies are being slowly pulled apart by the Milky Way's gravity, adding their stars to our galaxy's outer regions. This process shows that galaxies are constantly interacting, even when separated by millions of light years. From Earth, we can't see the Milky Way's entire shape directly because we're inside it. The view we get is like looking through a forest. You can see the trees around you, but not the whole shape of the forest itself. Still, when we look up on a clear, dark night, the glowing band that stretches across the sky is one of the most beautiful sights in nature. That band is the combined light of billions of distant stars in our galaxy's disk. It reminds us that we're part of something vast and ancient, and it connects us to every person throughout history who has ever looked up at the same sky in wonder. Even though we can't see the whole Milky Way with our eyes, technology allows us to explore it in ways our ancestors could only dream of. Telescopes that detect radio waves, X-rays, and infrared light let us see through the dust and gas that block visible light. Space missions like Gaia and the James Webb Space Telescope are mapping our galaxy in incredible detail. They can measure the positions, motions, and brightness of billions of stars, helping scientists build a precise 3D map of the Milky Way. This map shows how stars move and how the galaxy's shape changes over time, giving us a deeper understanding of our cosmic home. For astronomers, studying the Milky Way is like reading a history book written in the stars. Every region, every cluster, and every stream of stars tells part of the story of how the galaxy formed and evolved. From the ancient halo stars that date back to the universe's earliest days, to the young, bright stars shining in the spiral arms today, the Milky Way is a record of cosmic history. By studying it, we learn not only about our galaxy, but also about how all galaxies in the universe might have formed and grown. The Milky Way's story begins long before our Sun or Earth even existed. In the early universe, after the Big Bang, there were only simple elements like hydrogen and helium. Gravity slowly pulled these gases together into small clumps, which became the first stars and galaxies. Over time, these small galaxies merged to form larger ones. The Milky Way likely started as one of those smaller systems, growing larger over billions of years by pulling in nearby gas and absorbing other galaxies. Each collision added new stars and reshaped the structure of our galaxy. That means parts of the Milky Way once belonged to completely different galaxies that no longer exist. Even today, the outer edges of the Milky Way show signs of these ancient mergers, like faint trails of stars stretched across the sky. The shape of the Milky Way has changed many times over its long life. At first, it may have been more irregular, without clear spiral arms. As it spun faster, gravity and density waves caused it to flatten into a disk and form the beautiful spiral structure we see today. These spiral arms aren't solid objects. They're regions where stars and gas are more densely packed, like traffic jams in space. Stars move in and out of them over time, but the spiral pattern stays. This wave-like motion keeps the galaxy organized and helps trigger new star formation. The Milky Way spiral arms are like the heartbeat of the galaxy, always moving and pulsing with new life. Inside the Milky Way, not all stars are the same. Some are huge and burn bright for a short time, while others are small and can live for trillions of years. Our Sun is a middle-sized star, known as a yellow dwarf, with a stable and long lifespan. Around it orbit the planets, including Earth, which formed from the leftover material after the Sun was born. Our solar system moves around the galaxy, along with billions of others, following a path that takes about 230 million years to complete one full orbit. That means since dinosaurs first appeared on Earth, our planet has only traveled about 1/4 of the way around the galaxy. The timescales in astronomy are so vast that it's hard for the human mind to imagine. In addition to stars and planets, the Milky Way contains huge amounts of dust and gas. This material is what makes the galaxy look cloudy and hazy when seen from Earth. It also plays a key role in forming new stars. When clouds of gas become dense enough, gravity pulls them together until they collapse and ignite. The Milky Way constantly recycles its material this way. Old stars die and release gas back into space, and that gas forms new stars and planets. It's a cycle of death and rebirth that has kept the galaxy glowing for more than 13 billion years. If you could watch the Milky Way over time, you would see it changing shape as new stars appear and old ones fade away. Some of the most fascinating objects in the Milky Way are its star clusters. These are groups of stars that form together from the same cloud of gas. There are two main types: open clusters and globular clusters. Open clusters are younger and located mostly in the galaxy's disk. They often contain a few hundred stars that are loosely bound together. Over time, they scatter as the stars drift apart. Globular clusters, on the other hand, are very old and tightly packed. containing hundreds of thousands of stars. They orbit the galaxy in the halo, far above and below the disk. These ancient clusters are like fossils, giving scientists clues about what the early Milky Way was like. As our technology improves, astronomers can study the Milky Way in more detail than ever before. The Gaia space mission, launched by the European Space Agency, is one of the most ambitious mapping projects in history. Gaia is measuring the positions and motions of more than 1 billion stars, creating a 3D map of the galaxy with incredible precision. This map helps scientists understand how stars move, how the galaxy rotates, and how it has changed over time. By watching how stars drift and cluster, researchers can even trace the Milky Way's past collisions with other galaxies. It's like watching a slow-motion video of the galaxy's life over billions of years. The Milky Way is also an important laboratory for studying the laws of physics. The motions of its stars help scientists test theories of gravity and dark matter. Because dark matter doesn't emit light, we can't see it directly, but we can observe its effects. For example, stars on the outer edges of the galaxy move faster than they should if only visible matter were there. This means something invisible is adding extra gravity, and that something is dark matter. By studying how stars move in the Milky Way, astronomers can estimate how much dark matter there is and how it's distributed. So even though we can't detect dark matter with telescopes, the Milky Way gives us a way to study it indirectly. Another mystery is dark energy, a force that makes the universe expand faster over time. While dark energy affects the universe on large scales, it also influences how galaxies like the Milky Way evolve. Understanding how our galaxy fits into the larger picture helps scientists explore these deep cosmic questions. In a way, studying the Milky Way is like looking into a mirror that reflects the universe's history. It tells us where we came from, what we're made of, and where we might be going. Within the Milky Way, there are also countless fascinating objects beyond stars like pulsars, quasars, and black holes. Pulsars are rapidly spinning neutron stars that send out beams of radio waves, like cosmic lighthouses. When those beams sweep past Earth, we detect them as regular pulses of energy. Some pulsars spin hundreds of times per second with amazing precision. Quasars are even more powerful. They're galaxies with supermassive black holes at their centers, shining brightly as they consume surrounding material. Our Milky Way's own black hole, Sagittarius A*, is much quieter, but sometimes it flares up when it pulls in gas or dust. Studying these phenomena helps scientists understand how galaxies form and how black holes affect their surroundings. Even though we've learned so much, there's still a lot we don't know about our galaxy. For example, scientists are still trying to figure out exactly how many stars it contains. Estimates range from 100 billion to 400 billion. We also don't fully understand how the spiral arms are maintained or how dark matter interacts with normal matter. And of course, one of the biggest mysteries is whether intelligent life exists elsewhere in the Milky Way. With so many stars and planets, the chances seem high. But so far, we haven't found clear evidence of other civilizations. Some scientists are searching for radio signals from distant worlds, while others are studying exoplanets that might have conditions like Earth's. The Milky Way could be full of life, or we might be alone. Either way, the search continues. For humans, exploring the Milky Way has always been more than a scientific quest. It's also an emotional and philosophical one. When we look up at the stars, we feel a sense of wonder and curiosity that connects us to our ancestors. The same stars that guided travelers and inspired myths thousands of years ago are still shining today. Modern science gives us tools to understand what those stars really are and how they're part of a vast galactic family. But even with all our knowledge, the Milky Way still inspires awe. It reminds us that we're tiny but meaningful pieces of a much larger story. When we study the Milky Way, it's hard not to feel amazed by how perfectly balanced everything seems. Every part of the galaxy plays a role in keeping it stable and alive. The spiral arms bring together gas and dust to make new stars. The old stars in the halo and bulge act as reminders of how long the galaxy has existed. The dark matter halo provides the gravity that holds everything together. Even the space between the stars, which might look empty, is full of radiation, cosmic rays, and magnetic fields that influence how the Milky Way functions. All of these parts work together like an enormous, natural machine, fine-tuned by gravity and time. The Sun and its planets are just one small part of this massive system, yet it's interesting to think about how lucky we are to be in such a calm and safe region of the galaxy. If Earth were too close to the galactic center, the intense radiation and frequent supernova explosions could make life impossible. If we were too far away, there might not be enough heavy elements to form rocky planets. Our position in the Orion Arm, halfway between the center and the edge, gives us the perfect balance. It's quiet, stable, and full of the materials that support life. Some scientists even call this region the galactic habitable zone, meaning it's one of the best places in the Milky Way for life to exist. Even though we've mapped much of our galaxy, there are still parts we can't see. Huge clouds of gas and dust block our view in many directions, especially toward the center. To look beyond those obstacles, astronomers use telescopes that detect different kinds of light, like infrared, radio, and X-rays. Each type of light reveals a new layer of the galaxy. Infrared light shows warm dust and hidden stars, while X-rays expose energetic regions near black holes and supernovae. Radio waves help us trace the cold gas that forms new stars. By combining all these observations, scientists can build a complete picture of the Milky Way structure. It's like putting together a puzzle made of invisible pieces. The more we learn, the more we realize that the Milky Way isn't standing still. It's spinning, moving, and interacting with other galaxies all the time. Our entire galaxy is traveling through space at more than 1,000,000 miles per hour relative to the cosmic background radiation, the faint glow left over from the Big Bang. Everything inside it, from the smallest asteroid to the largest star cluster, shares that motion. Yet, because everything moves together, we don't feel it. To us, It seems like we're standing still, even though we're flying through space on a vast cosmic journey. Some of the most exciting discoveries about the Milky Way have come from observing other galaxies. By comparing them, astronomers can learn what makes ours special and what it has in common with others. For example, the Andromeda Galaxy looks similar to the Milky Way, but is about twice as large. Studying Andromeda helps scientists predict what will happen when the two galaxies eventually merge. Other galaxies show different shapes. Some are spiral like ours. Others are elliptical or irregular. By looking at these examples, we can see the stages galaxies go through as they evolve. The Milky Way is currently a mature spiral galaxy, full of both old and young stars. But billions of years from now, it will probably change shape after merging with Andromeda. Closer to home, our solar system's journey through the Milky Way has shaped Earth's history in subtle ways. Some scientists think that as the sun moves through different regions of the galaxy, it may pass through areas with higher levels of cosmic radiation. These shifts could influence Earth's climate or even the rate of biological evolution. For example, when the solar system moves through dense gas clouds, it could slightly affect the outer edge of the solar system, where comets are stored. Occasionally, this might send comets toward the inner solar system, possibly leading to impacts on Earth. While these events happen over extremely long periods, they remind us that we are part of the galaxy's constant motion. The Milky Way also contains countless wonders that we're still discovering. There are stars so massive that they burn out in just a few million years, and others so small that they might shine faintly for trillions of years. There are black holes scattered throughout the galaxy, formed when giant stars collapse at the end of their lives. Some of these black holes are alone, drifting silently through space, while others are part of binary systems, feeding on nearby stars and releasing powerful X-rays. Then there are strange objects like magnetars, neutron stars, with magnetic fields trillions of times stronger than Earth's. Every one of these objects tells a piece of the Milky Way story, showing how diverse and extreme the universe can be. In recent years, astronomers have discovered that the Milky Way might have a faint extended structure beyond its main disk. Some call it the stellar halo, or the outer disk. It contains stars that orbit at great distances, perhaps 200,000 light-years from the center. Many of these stars may have come from smaller galaxies that were torn apart by the Milky Way's gravity long ago. Their orbits form long, thin streams that wrap around the galaxy like ribbons. These stellar streams are like footprints from the past, allowing scientists to trace how the Milky Way grew by absorbing other galaxies. It's a reminder that even something as big as our galaxy is shaped by a long history of cosmic mergers and collisions. While the Milky Way looks peaceful from our perspective, it's actually full of powerful forces. Gravity is the main one, holding everything together. But other forces like magnetism and radiation also play important roles. Magnetic fields run through the galaxy, influencing how gas moves and how stars form. These fields are invisible but can be detected by measuring the polarization of light from distant stars. Cosmic rays, which are high-energy particles from supernova explosions, travel through these magnetic fields and interact with gas, creating faint glows that radio telescopes can detect. These invisible forces give the Milky Way its texture and energy, shaping how it changes over time. Despite all the knowledge we've gained, the Milky Way remains a place of mystery. We've only explored a tiny part of it, just the space around our own Sunday. The nearest star, Proxima Centauri, is over 4 light-years away, and even that distance is enormous by human standards. With current technology, it would take tens of thousands of years to reach it. That means our understanding of the galaxy comes entirely from what we can observe through telescopes and instruments, not from direct exploration. But one day, humans might send robotic probes beyond our solar system to study nearby stars up close. Those missions could be the first small steps toward exploring the Milky Way for real. For now, though, the night sky gives us our best window into our galactic home. When we look up from a dark place far from city lights, the Milky Way stretches across the sky like a river of light. Each tiny sparkle is a distant sun, part of a vast family that includes our own. It's humbling to think that all of human history, every culture, every story, every dream has unfolded inside this one galaxy. The Milky Way isn't just a collection of stars. It's the setting for our entire existence. Every atom in our bodies, every grain of sand, every drop of water, all of it began inside ancient stars that once burned in the Milky Way's depths.